Hello, everyone, and welcome to Programming in Robotics today. My name is Professor Angela Wells. I am a member of Black In Robotics, Chief of IoT for Lumina Energy, and today we are going to actually have a Programming in Robotics workshop. This is an exciting field that combines the power of coding with advanced robotics technologies to create intelligence machine capable of performing a wide range of tasks. And so I'm going to allow everyone to introduce themselves and the TAs. And so I'm going to pass this off to the instructors, Alex.
Hi, my name is Alex. I'm a fifth year robotics PhD student at CMU, and I do robot motion planning.
Okay. And who would you like to pass it off to?
Okay, we'll do it like that.
Yes.
How are you? The next person on my thing is Christopher.
The mission of Black Robotics. Blacks in Robotics is an organization equalities found in our robotics community by focusing on three primary pillars: community, advocacy, and accountability. We want to bring robotics community together around these initiatives. Black in Robotics brings together a global network of Black roboticists, allies, organization sponsors, contributing to the goal of enhancing diversity, inclusion of equality in robotics. We believe that to we believe to see an increase in presence of blacks and underrepresented minorities in robotics, and we must actively build communities advocates for diversity and encourage accountability. So today I'm going to turn it over to Alex, and Alex, you may begin.
All right, thank you, Professor Wells. Today, we are these are our learning goals for today. First is we are going to modify and write Python code. This is getting started in program. So writing expressions and calling functions that already exist. I want to highlight that this is an iterative process. We're going to make mistakes. There's going to be errors, and that's expected, normal, and we're going to work with that. The second is the robotics part. We will command a robot to go to a specific set of joint angles. So uh, yeah, like arm angles, and to a particular 3D location. The last goal for today is to sketch out a procedure of taking some robot behaviors that we now know how to do from that blue box, commanding the robot to do those things, to make something that's more complicated, like a dance or grasping an object. And the priority here is just to get confidence in getting started with programming and robotics. We want you to go back to the labs and to continue to work on it, to continue to develop your skills. Yeah, and we'll go back to these as at the end as well. Here are the kind of the expectations for this class. It's supposed to be quite interactive. There is some lecture component, but we try to keep it to a minimum. Most of the work and most of the learning will be with your TA in breakout rooms. The format that we expect is that one student will be sharing a screen at a time. Everyone fills out the code and the lab together on their own computers as well, but one student will be sharing a screen. Discuss and ask the TA questions. The TA can guide the discussion, but it should be a student who is typing out the code. We will also have the main room for these like lecture bits. And if there's anything that you can't resolve within your rooms, please come back to the main room. Finally, we expect everybody to treat each other with respect and kindness because everybody is important here. Also, if you have questions, please put them in the chat, and we can do our best to answer them during. I didn't write that on the slides, but anything else is to be talked about in the breakout rooms. So as a reminder, breakout room is for group discussion and working through the lab. This is where the learning happens. And main room is for lecture, where you'll see things, but it's okay if you don't learn it at that point. And any sort of troubleshooting with the lab if there's something that isn't working. All right. Oh yeah, and please rotate who shares and ask questions. And for pacing, prioritize anything that says it's not a challenge, and you can come back to the challenges. And if you get stuck on any one part for more than 5 minutes, that's not what we expect. It's not that anything is going wrong, but please come to the main room so we can figure out what's blocking people. This is the structure of the class. First, we're going to do some basic programming stuff. The longest lecture bit will be right here of just some of programming. Then we'll do our first breakout room session for 20 minutes. Then most of the lab happens here. There will be a 5-minute lecture given by TJ. Then we will have 40 minutes in a breakout room. And finally, we will do a wrap up with another short lecture and then the third part of the lab. Finally, we'll come together, share lessons learned, discuss together. So this is the format. And we'll start with the programming part. So first, a way you can think of programming is like a recipe. So we have definitions and we have commands. A definition is a label for something. So we can have a slice of bread called slice 1, a different slice of bread called slice 2, and jelly. To do things with these slices, we have commands, which are actions or instructions. An example of a command is to spread or to place. This is an example of what a recipe for a peanut butter and jelly sandwich may look like. I'll just highlight 2 examples. So second is spreading. This is the action. Jelly, which refers to this, on slice 1, which refers to this. And you can do something like place slice 1 on top of slice 2. So this is doing actions with the objects. In coding, it's a language, and like any other language, like Spanish or like Chinese, it has rules of how letters and numbers need to be arranged and what that arrangement means. So in math, we decide that putting a plus sign between numbers indicates to add those 2 numbers. Similarly, in Python and many other languages, when we're giving a definition to a label, we put the label on the left side, you put an equal sign between them, and we put the definition on the right side. So this is just an example of the rules for the language. There are many different types of programming languages. There's Python, which looks like this. Some of you have also maybe worked with other languages such as Java. And yeah, if you want to shout out any other programming students, any programming languages that you've learned, feel free to type those out in the chat. And here are the concepts we're going to learn. There are many other concepts in programming and in Python, but we're going to focus on these building blocks. One of them is variables, which are those names. Next is printing something to the screen, so outputting something to the screen. Commenting, which explanations for code. This one is really important. This one is functions, so doing things with existing libraries or tools that other people have created. And finally is lists, a collection of objects. So first we'll start out with printing. Printing outputs text to your screen. For instance, when you're printing, you put the text in quotation marks and it will show out on the screen. For this part of the lesson, I'm also going to show an example in Python. So look on the left side of the screen. So if I want to print, my name is Alex, I do print. These parentheses indicate a function, which we'll go through again. But for now, just you can just think of it as print, then parentheses, the text in quotation marks. My name is Alex, and it will output on the screen. All right, and I'll give like 5 seconds for people to put questions about print. This one tends to not get questions, so TAs can answer if people have that. All right, next is comments. A comment is a hashtag next to text, and you're supposed to use it to explain code like this. This is printing code. Now, when you're explaining code, it doesn't actually run anything, so it can, yeah. Accordingly, you can also put a hashtag next to code that you don't want to run. And in the lab, we will be using this as a tool. So this, if I put print hi here with the hashtag next to it, it won't run. Next is variables. Variables are how we assign labels to data. We're reviewing this again because this is really important. This is one of the building blocks. The value goes on the left, the variable goes on the left, and the value goes on the right. So if I want to create a variable called variable name, I put it here, equal sign, and the value on the left, on the right. Then I can print out that variable. Let me do a slideshow mode. Oh, that's unfortunate. Okay. This is functions. So functions take in an input called arguments. So in a divide function, the arguments are numerator and denominator separated with a comma. So these are inputs. The inputs can be empty as well. Functions do something. When a function does something, we say we're calling the function. And lastly, a function outputs something, which we sometimes call return, which can be nothing. So a function can do something and not return anything. There could be no outputs. For instance, if we call divide, these are inputs, 1 and 2. The call will do the division operation, and the output is the result of dividing 1 by 2. And if we the order of the inputs matters, so if we do divide 2 by 1, we get a different value. Next two concepts are about lists.
And assign it to X, and then it will print. Any questions about functions? Okay, moving right along. Either you're so clear or you're totally bored. One of the two. Okay, so the last concept I want to talk about are lists. So lists are another way that we can store data other than just in variables. Lists allow us to store a collection of data. So let's look at the syntax for this. So for a list, it starts with an open bracket, and then it's followed by a series of things separated by commas. Here, our list contains numbers, so we have our numbers separated by commas, and then a closed bracket. So here, let's assign this list the label X, and then when we print X, we get our list. Can folks in the chat type a different list? Just any example list. So here I made a list of 1, 2, 3, 4. Maybe make a list of 5, 6, 7, 8. What would that look like? Pop it in the chat. Awesome. So Anne's made a list of 5, 6, 7, 8. And Werner, if I'm saying your name right, if I butchered it, I'm sorry, is making a list called list 1. And it has 2, 3, 5, 7. Nice. Okay. So next I want to talk about modifying lists. So I showed you about how you can use the brackets to define a list. You can actually use the brackets also to index into the list. And so each element in the list has an index, and indices start at 0. So the first thing in the list here is 1, and it has index 0. The second thing is 2, and it has index 1. So if we want to access items in our list, we can take the name of our list, open bracket, a number, which is the index we want to get, and a close bracket. So here, if I take my list bracket, open bracket, 0, close bracket, that'll get me the thing at index 0, which in this case is 1. So show you an example here. So here, if we have this list 1, 2, 3, 4, if I print X of 0, this will print 1. So what happens if I print X of 3? Can people put in the chat what that will print? Okay, I'm seeing 4. Any other answers? Anyone disagree? run it, and we got 4. Cool. Very important to understand the indices started at 0. Okay. So I talked about how we can index into a list. Well, because we can index into a list, we can actually modify what is at that index. And so here I'm taking what is at index 0 and I'm assigning it a new value, which is 10. Do an example here. So if I take x of 0, and I'm now going to assign it the value 10, I print this, I now have the list 10, 2, 3, 4. Let's take x of 2 and make it 11. What will this print when I print x? Pop it in the chat. They're all so smart, so I know someone will get this right away. I set what was at index 2 to 11. So now what's my list? All right, I'm seeing 10 to 11, 4. Any other answers? All right, another 10 to 11, 4. Let's run it. And yep, we've got 10 to 11, 4. So on this line, line 2, we made x of 0, 10. And on line 3, we made x of 2, 11. So now we've changed 2 items in our list. Any questions about lists? Indexing into lists, modifying lists? You have any questions?
Okay. Looks like people are back. Yeah, I think TJ, it's whenever you want to go for it. To start.
Okay, can everyone hear me okay?
Mm-hmm.
Cool. All right. Yeah. So sorry, things are a little weird. I'm using my phone as my microphone, so bear with me here. But I'm TJ. I'm a third-year mechanical engineering student, PhD student at Carnegie Mellon, and I'm going to be talking about the robotics aspect of this lab. So first of all, what is a robot arm? So many of you have probably seen them in movies, or if you've been in a robotics program, you've seen them before. But it's defined as a programmable machine that can perform repetitive tasks accurately. It's defined by also resembling a human arm, which we'll talk about a little bit more. And they can collaborate with humans, or they can replace dangerous human tasks. So they can work together with humans, or just completely, take over the job as well. So talking about the anatomy, so it's very similar to actually a human arm. It's kind of how robot arms were kind of inspired by. So in a human arm, you have the shoulder joint, you have the elbow joint, you have your wrist joint, and then you have your hand, which is an end effector. And an end effector is basically anything at the end of an arm or a robot arm. In our case, it's going to be a gripper, which we'll talk about at the end. But I think this is blocking. Here we go. Yeah. But in robots, we can control the arms by commanding the joint angles. So you can see there's 3 joints here, and each joint has an angle. And if we just tell the robot to move to a certain joint angle, then the whole robot arm is going to move somewhere. So that's pretty much the core concept of this lab, just to really understand and hammer down. So also feel free to ask questions throughout the lab. I know this is kind of more the complex section. So yeah. Okay, so like I mentioned earlier, joint angles are kind of basically just the angles of the joints of the robot arm. It doesn't have to be just 3, it can be 6, 7, 8. It just really depends on the geometry of whatever you want to make your robot into. So they basically indirectly specify the position of the robot parts. So in the chat, just making sure y'all paying attention, just want to see how many joint angles does this robot on the screen have. Okay, 3. Yeah, there we go. All right, cool. All right, moving on. So also position. So I'm sure all of you have heard about position in other contexts, but in robotics, position describes where the object is typically in 3D. So it's basically kind of the mathematical description of where this object is. So for example, this red block here is basically 0.1 units in the X direction, 0.1 units in the y direction, and 0.1 units in the z direction. And that is our position, basically. So here's where it gets a little complicated. So just bear with me here and feel free to ask questions. So there's two major ways where you can command the robot to get to a certain position of interest. So first, we have forward kinematics. So you basically start out knowing the joint angles. So let's say you have some kind of sensor that can know exactly where the robot joint angles are. And let's say you want to get the arm to some kind of position. You use something called forward kinematics, which is basically a set of equations and a set of functions that will translate the angles into the position. So here, the angles, what you want to really just hammer down here is that for forward kinematics, the angles are the input and the position is the output. And we just want to know the position of the gripper at the end. And the opposite of this is inverse kinematics, where first you start with the position of the object or whatever you want to sense. So let's say we have a camera that can see exactly where this apple is on a table, but we don't know how to get the robot there. So you use inverse kinematics which is also another set of equations and functions. And that will basically translate that position you get from the camera to the joint angles that the robot needs to command to pick up the apple. So you don't need to know how the math works at all. Just kind of know that these things exist. You're going to be able to use functions like this in the lab. So just kind of a general overview again. Once again, forward kinematics start with angles and with position. And the opposite is for inverse kinematics. So you start with position and then you end it with your joint angles. So I know that's kind of a lot of information, so feel free to ask questions in the breakout rooms, but I'm going to pass it back to Alex.
Quickly. So, when you do this, it makes you raise your hand. So now I'm raising my hand. Okay. Cool. I hope that was just super clear, which is why no one has questions. All right, I will pass it back to Alex. I will just stop sharing my screen. Also, thank you for everyone for participating. Appreciate that.
Yeah, that was good participation. I think the lab will go pretty well. All right, we're gonna run code on the internet. Here is how we're going to do it. There's a lab link that will get sent around in the chat multiple times. And it's gonna look kind of like this. To edit code, you double click the code block and then you type on it. And we'll show an example of this. To run code, there's a play button next to the code block on the left. So you can click the play button and then read the output below that block. And to edit text, it's the same thing as editing code. You double click the text and then you type. So there'll be places where you can write your own answers to things. So you can save them and go back to them. There's two parts to this. The first is there's going to be a discussion. These questions will be at the top of the lab. So you'll introduce each other with your name and some starting questions. This should take about 5 minutes. Then there will be a lab that will be 10-15 minutes. We'll check in at some point to see where people are at. There's kind of a lot of text that's explanatory, but you only really need to read the text in bold to do the activities. Remember, one student should be sharing a screen, and students should be talking most of the time. Ray and I are going to practice being in a breakout room. I'm going to put this link in the chat as well. And then we're going to do the pretend breakout room, so y'all can get an idea of what we're looking for. Yeah, we'll send this again once people are in the breakout rooms as well. So in the meantime, Ray and I are going to pretend I'm going to be a student, and Ray is my TA. So that means I'm sharing my screen. And here I am in the code. I just ran the code, and I saw an error. All right, Ray, help me. I just ran the code and it says that there's a syntax error in this change code for comment exercise here.
Okay, so can you read me the bold, what's at one?
One says run the code below. It should cause an error. Okay, so it should cause an error. So this is a good thing.
Yes, that's what we want. All right,
okay.
What does the second thing say?
All right, then turn the second line into a comment.
Okay, do you remember how we make comments?
Something with a hashtag, but I don't remember exactly.
Yeah, so if you go to the code there to that first line where it says
Mm-hmm.
change code for comment exercise, that comment,
Yep.
the first line.
Oh, I see. Yeah, with the hashtag in front. Okay.
So now how can you make that second line a comment? How can you comment it out?
I can also put a hashtag in front of the code.
Yeah, so why don't you try that? Okay, and then run.
Okay. Yay, there's no error. All right. Thank you, Ray. And I'm now going to switch it to another student who will continue the lab. All right, so that's our practice activity. Questions about logistics for the lab before we go out into our breakout rooms? Okay, all right. Remember, come back if you're running into any trouble or want to join a different room. I think everyone is assigned to one, so you'll get an invitation, and I think you should be able to move yourselves if you just want to switch rooms. And there should be one TA per room. Oh, interesting. Okay, we had a TA who just left. All right, I will open these rooms. So they'll be a little bigger than expected. Maybe here and okay. Here. All right. Rooms will open. Yeah, have fun with the lab and see you in about 15 minutes. Mm. All right. So now we're at the wrap up, which will be another short lecture, and then we'll have some time in the breakout room to do another short part of the lab, and if you choose to, a discussion, and then we'll come back at around 4:20 Eastern time for just wrapping up and talking about future things you can do with Black in Robotics. So here is TJ, our instructor, who is not here today, but I think this is an arm that he either found or uses. So we can move this arm, but how do we actually pick things up and do useful things? So here's like kind of a rough procedure that you can follow to grasp most objects. And this does things that you either know how to do or are pretty close to knowing how to do. So first, move to a location above the object. Then open the gripper, which is usually just calling one line of a one-line function. Move down to the object, another location in 3D space. And finally is close the gripper to something slightly less than object width. So this is a procedure for grasping. And there's some fill in the blank stuff you can do to have your robot grasp something. To place, it's just the reverse. So lifting the object, moving to where you want to place it, moving down to the placement location, and then opening the gripper. So questions in chat regarding this like procedure for pick and place? Okay, I actually can't see chat anymore, so Ray, please let me know if someone puts a question in chat or answer it. Robots can do other things. What was that?
I was gonna say, yeah, I don't see anything in chat.
Okay. Or you can unmute yourself too. That's fine. Robots can do surgery, they can clean your house, they're used in manufacturing applications, and we also see them on social media dancing in Boston. So here's the activity. There's two potential ones you can do. You can pick which one. So there's do a dance move. There's some sample code that does some dance that I made, so you can make it much better. Option 2 is a grasping lab, where you'll have a robot go to grasp an object, And then last time we had people actually making ways towards the robot picking it up and moving it somewhere. We don't expect you to necessarily finish these by the end of, we'll give you 10 minutes to do this, but hopefully you'll be in a good enough spot that you can save the lab and then come back to it, and then work on it on your own time. And you can always ask us for questions if you get stuck. The third option is if you don't feel like coding anymore, your group can decide to do this discussion question, which I believe is updated in the lab. Let me know if you'd like to do this and it's not. The gist of it is that you have a robot like what you have now, but it's on a wheeled platform and it's in a farm, and you want it to pick strawberries. So describe some steps that you would write into code, that you already kind of know how to do in order to pick the strawberries, and consider things like how do you move it to the right place? Once you know where the right place is, how do you grasp it? And what's different between doing this with a block and a strawberry? So in your rooms, pick which either coding activity or discussion you want to do. And then, yeah, we'll wrap it up. If you need to finish the lab, then I do recommend at least doing the first few lines. Try to do it quickly if you can, because you'll apply it in the next parts. All right. Welcome back to your rooms, and same procedures as always, and see you in about 10 minutes. All right, thank you, TJ. All right, again, there's information there. It's a lot, but it will make more sense as you start working with. So we're gonna go back into the breakout rooms. This time you can go if you want to continue working on programming. You should join the programming breakout room. You can come here and we can assign you to it if that's what you want. And everyone else, you can move through rooms. We'll probably move a couple people into room 4 just so we're a little bit more split up now that we have more TAs. So I'm going to add one more room, and yeah, I'm going to reassign everyone, I think. No, okay. Open all rooms. And again, if
Okay, like 10 seconds. Yeah, there we go. Okay, cool. Yeah, so that is definitely a consideration. So basically what we want the robot to do is basically what I explained in the last slide. We want to basically move to right above the strawberries position, close, and like Kaya said, strawberries are smaller than blocks, so you can't squeeze it too hard. So you have to kind of figure out what is the right grip width that you need to make sure you don't destroy your object. So if you're ever designing robot arms, just make sure you know about how squeezable your object is. But yeah, great job, everyone. So now we'll move into the summary and finish this up.
Yep. Yeah, so what we did today was we learned how to change and to write Python code. We commanded a robot to go to joint angles into a 3D location, and did something with a complex robot behavior. Next slide, please. Oh, yeah. In chat, please write one thing that you learned today. It doesn't have to be one of our learning goals. Yeah, something you learned. Or did today. That's also nice to see. And then lastly, so while people are writing that, let's go to resources, and then I'll hand it off to Professor Wells.
Okay.
So save your lab notebook. You can keep the code, and that way you can reference it and then use it and build on it. There's some more information about it. You can. I'll leave this for Professor Wells. We have our contact information here. You're welcome to ask us questions about it. Yeah, thank you so much for joining us. All right, it's all yours, Professor Wells.
Thank you. And we want to say thank you for exploring programming in robotics with us today. And we hope you gain valuable insights, into coding. And this is what we want you to continue to do. Keep learning, experimenting, and pushing the boundaries of what's possible with robotics. And hey, let's change some lives together. Thank you for attending today's workshop. Have a great Sunday afternoon.